concept in programming. They allow you to store and reuse your data in various places all throughout your code. Let's say we have a situation where we're trying to set the position of some transform. Now after setting this position, let's say we have some more lines of code, and then we need to come back and either reset the position or reuse that value for something else. We could attempt to remember what those values were and type them in again. But that becomes very labor intensive and very prone to error. We have to remember what the value was, and we have to be sure to reuse the exact same value. And if we change one instance of those values, we'd need to go and find anywhere else we use those values and change those as well. This is in fact something called hard coding, and it's generally not a good thing to do. We don't want to hard code values throughout our scripts. Instead, we should probably store those in something called a variable. A variable is basically just a storage container or a bucket of data. There are different types of variables, and those variables store different types of data and are used in different ways. For instance, this vector3 is a data type, and it reads in and stores 3 float values. A more robust listing of the different data types and how they're used will come in a later section. For now, we really just want to cover the concept of these variables. So let's say I want to remedy the situation we have right here, where we don't want to keep hard coding these values for the position of this transform. Instead, what I'm going to do is I'm going to declare a new variable. It will be of type vector3, and then I will use that to set the position of the transform. So now what we have is a single instance of those values 2f, 2f, and 2f stored inside of vector3, which I've named myPos, kind of short for my position. Then anywhere I need to access that value, I just use the name myPos. Now you can see on lines 10 and 14 that transform.position is set to the value myPos, or my position. Now if I ever need to change the value of myPos, I do it in one place, and all the references to that data are updated automatically. Additionally, since transform.position is in fact of type vector3, I can use that to set the value of a vector3. So let's say I wanted to temporarily store the position value of a transform into a vector3, do some work on it, and then put it back. The code would look something like this. Now we can see we are creating a variable named myPos and setting it equal to the position value of our transform. Then we do some work and simply put it back on line 12. There are many types of variables, and again, we'll have a more complete list in a later section, but all variable declarations follow a specific pattern or have a specific syntax to them. In C#, a variable declaration, that is, when we create a variable, starts with the data type of that variable. The data type specifically denotes the type of values that can be stored inside of it. So if I wanted to create an integer, I would type the letters int, or int, which is short for integer. Now that I know the type of the data, I need to give it a name. I can choose any name I want, but there are a few rules. First, there can be no spaces in the name, and there can be no special characters. The name can have numbers, but it can't start with a number. In this instance, I'm going to name this myValue2 just to show you some of the ways we can write this. Now that we have a variable declared, we could leave it just like this and end with a semicolon. That ends our code statement. If we wanted to, we could also initialize this value or give it some value. We could do that by just using the equal sign and specifying what myValue2 equals. Now we have an integer named myValue2 that's set equal to the value 16. There's a common standard when naming variables, generally referred to as something called camel case. In camel case, the first letter of the variable is lowercase, and the first letter of each additional word in a variable name is uppercase. So if I were to create a variable, this time of type float, with the name myNewValue, you can see that the m in my is lowercase, the n in new is uppercase, and the v in value is uppercase. This is not required, but as it is a standard, most people will recognize that and want to use it. Another very important concept when dealing with variables is the concept of scope. Scope defines where a variable can be used. Generally speaking, a variable can only be used within the same block that it is declared. A block is denoted by an open and closed bracket. We can see that the brackets on line 7 and line 16 open and close a block of code. Now, if we had another method, this time the update method, and we wanted to use, say, a variable myValue2, we couldn't because it is in a different block. As a matter of fact, we will see the variable name myValue2 appear in red, denoting that this is not an OK use and we have an error. As you can see, lines 7 and 16 open and close a block that stores myValue2. Lines 19 and 21 open and close a different block. We will often have a block inside another block of code, and in that case, the scope of the variable does work inward. Let's take a look at how. I know we haven't looked at conditionals or if statements yet, so just bear with me, we'll cover those in a later section. But what we have now is a block within a block. Line 18 and line 20 define a new block inside the block started by line 7 and line 21. In this case, we still have access to the variables myPause, myValue2, and myNewValue, because even though they aren't in this very specific block, lines 18 and 20, they are still within the overall block. Therefore, we can still use them here. It may seem confusing trying to remember where blocks are and what can access what, but it's a skill that gets easier with time and it's fairly intuitive. Now let's say we give a value to a variable inside our start method and we do want it to be available inside our update method. Obviously, our blocks don't really go inward from here, so where can we go? The answer is we can step out one more block. You may notice that lines 5 and 22 define even another block. That's the class level block. It's the block that contains all of the code in this class sample script. I have the ability to declare variables here, and here they will be globally accessible within this class. It's worth noting that if I declare the variable myValue2 on line 6 at the class level or global level to this class, there's a slight issue with line 16. We are now declaring two variables of name myValue2, and they're both within the same block. This will cause an error, and depending on your IDE or your text editor, the error will appear in different ways. Either you'll get a message saying that you can't do this, or, even worse, you may not get a message, and instead, at runtime, while your game is being played, it just won't behave correctly. If we're going to do this, it's important to remove the declaration of the variable on line 16, so we're simply using it and assigning a value to it. Now the variable myValue2 being used on line 16 is the one that's being declared on line 6. And since myValue2 is being declared at the class level, it's accessible not only in the start method, but also the update method and any other methods that exist inside this class. Now that we understand more about variable scope, and we understand a little bit more about how they're declared and used, let's take a look at another example. Let's say we want our script to move an object along the positive z-axis. We can do so by using the translate method of the transform component. Again, like we saw in the last section, we're going to be sure to use time.delta_time to make sure this moves at 5 units per second as opposed to 5 units every single update frame. We may also notice though, based on what we've learned previously even in this section, that hard coding the value 5f is not necessarily a good idea. We generally want to avoid hard coding values like this. So what we might do is we might declare a variable named speed that is of type float that we will use inside this translate method. Again, following the pattern we learned earlier, on line 6 we start with the data type, which is float, followed by the variable name, which is speed, and then if we'd like to, we set a value, 5f. Now in line 10, we're going to remove the value 5f and we're going to replace it with the variable named speed. Now if we ever need to change that speed, we don't need to hunt for it in the code, we can change it right at the top of our class where we gave speed its value. Now let's go ahead and see this script in action. Back in Unity, we have a cube, and that cube has our sample script on it. Remember, that sample script is going to move this cube forward along the z-axis. And there it goes. Now, we may want to change how fast that cube moves forward along the z-axis. If we were a programmer, we could just go ahead and open up the script and make the changes that we want. But if you're not a programmer, or you're someone who's not familiar with the scripts that you're using, or maybe you just don't have a lot of time, that's not really a great option. You don't really want to go hunting through code to find the value that's going to give you the effect that you want. Instead, we can expose those values to the inspector here in Unity so that you don't need to go through your scripts for every little change you want to make. In order to make a variable appear in the inspector as a property of the script component, you need to set it as public. Public does a few things. Specifically, public makes a variable appear in the inspector, but public variables are also accessible outside of this class. So if I had another script that wanted to set the speed variable of sample script, I would need to make it public so that script could access it. Basically speaking, public variables are accessible outside of this class to be manipulated by other classes. Besides public, there's another type called private. Private specifically means that this variable is not accessible outside of this class, and no other classes can change it. We generally don't have to write private though, because private is the default value. By simply not specifying public or private, the variable is considered private. Now let's set this back to public, and let's go back into Unity and see what it does. Now that our speed variable is public, we can see that speed appears as a property of the sample script component on our cube. If we wanted this to be slower, we can simply change its value. We can also change this at runtime to speed up or even come back. If you're familiar with programming, you may be concerned by making variables public. That would make them accessible from anywhere without any real security, and that can often lead to errors. Another thing that you can do, if you don't want a variable to be public, but you do want it to be accessible inside the editor, is you can set it as a serializable field. You do that using an attribute that looks like this. The effect of this is to say that the variable speed is not public, it is in fact private, but we can still see it in the editor. As such, when we go to the editor, we can see that it is still a property of that component, and we still have the ability to change its value at runtime. The last thing you need to know about variables in this section is that their placement is important. For instance, currently I have my speed variable, which I'm using to affect my transform.translate method. I have it set up so that it appears in the inspector so I can change it without coming back into this code. If I move this variable declaration into the update method, however, it no longer works. I can't declare serialized fields inside methods, nor can I declare public variables inside methods. In order for a variable to be public and accessible outside of a class or accessible inside the Unity editor, it needs to appear at the global scope within our class. Generally speaking, we declare all of our global variables for a class near the top of the class before any of our other methods. With the correct placement, our variable will be visible in the inspector and will be usable in all methods inside a class.